Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. I teach online seminars for exams PFM, LTAM, and IFM. You can find information about them at smarturl.it/btdt-online. BTDT refers to the method of studying for actuarial exams that I think is the best. Call it BTDT, which stands for Been There, Done That. When you take an actuarial exam, whenever you look at any problem on the exam, you should be so prepared that you're able to say, been there, done that. You should have done all problems of the type that show up on this exam. You must know immediately what to do. There is no time for thinking on the exam. Thinking is the last resort of the unprepared. I authored an exam P manual, which you can get at smarturl.it/btdt-p, and the same for FM, LTAM, and IFM. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam FM. Which of the following is a correct expression for the present value of a perpetuity with payments of 1 at the end of year 1, 2 at the end of year 2, and so on until n at the end of year n, and then staying at n forever, so making payments of n at times n, n plus 1, and so on. And we have 4 choices, but it could be some of them, more than one that are this, so we'll have to think about it. And here's the solution. We first note that a double dot angle n over I is the same as 1 plus I times a angle n over I. Then we move that 1 plus I to the denominator, and this becomes a angle n over I divided by 1 plus I, and that's the same as a angle n divided by d, so the first two answers are the same. The first two answer choices are the same, but a double dot angle n times a angle n over id, that's the product of the first two answers, so it's not equal to any one of them, and it's also not equal to 1 over id, because that would require a angle n times a double dot angle n to be 1. That is not going to happen unless n is 1 and the interest rate is 0, but in general it's not true. And of course, we're actually not studying this with the assumption of interest rate of 0, because then the formulas wouldn't make sense. So the first two answer choices are the same, but the other ones are different. The cash flows described here have the same present value as an increasing perpetuity starting at time 1 minus an increasing perpetuity starting at time n plus 1, and therefore that present value is then when I say starting, I mean the moment of the first payment. So the present value is IA angle infinity minus v to the nth times IA angle infinity. I have IA for an annuity immediate because the first payment is at time 1 for the first one and at time n plus 1 for the second one. The IA angle infinity is equal to 1 over ID. You should know this. If you don't know this, memorize it for the test, and then deferred by n years, that's still the same thing, v to the nth times 1 over ID. And so this is equal to 1 minus v to the nth over ID, and you can write this as a angle n over d, but it's also equal to a double dot angle n over I. That means that the first two answer choices are correct, the other ones are not. That's answer A. But let's also note that a standard increasing perpetuity due starting at time n has the present value of v to the n over d squared. That's one of the three formulas in my study manual I ask you to memorize about payments, three types of payments: single payment, level annuity, and increasing annuity. And the standard increasing perpetuity immediate starting at time n has present value. So the first one was perpetuity due, this is perpetuity immediate. Well, that would be v to the n plus 1 over d squared, using the same logic, because now the first payment is at time n plus 1, because it's perpetuity immediate. And then we can write it as v to the nth over 1 plus I, so we move the one of the v's to the bottom, times I over 1 plus I, that's d, and the other d is left alone. So 1 plus I cancels, and this becomes v to the nth over I d. That's a way to remembering. That's a way of remembering that increasing perpetuity immediate. Let's have it valued at time 0 with the first payment at time 1. So standard increasing perpetuity immediate has a value of 1 over ID, and if the reference point in time is time n, and the first payment comes at time n plus 1, then it's v to the nth over id. In any case, answer A is what we're looking for. Please remember, this is copyrighted material. It's written by me, created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.